Hi guys, I'm Shamanna Sarkar. Welcome to my channel Net Practice for CSIR Net Mathematical Sciences. Now we are going to solve question number 13 from part C, December 2019 Net. In this question, a linear transformation from an n-dimensional vector space over the field of complex number into itself is given and the dimension has to be greater than 2. And the linear transformation T is such that the only eigenvalue is 1. So 1 is the only eigenvalue. And we have to identify the correct statement. Because it's a part C question, so multiple options may be correct. So we have to check every options. So look at the first option. It says that T to the power k will not be equal to the identity matrix I for any natural number k. Here, if we can find a linear transformation satisfying the property that 1 is the only eigenvalue, and if that linear transformation contradict some options, then these options will be wrong. So let's take T as the identity transformation, that is T of Z will be Z. So the matrix representation of T will be the identity matrix. So 1 is the only eigenvalue of T, which is basically I, the identity matrix. Since T is the identity transformation, so we can write T to the power 1 is equals to I, and 1 is a natural number. So for the identity transformation, the option 1 does not hold. So the option 1 is not true. Now check option number 2. For option number 2, we'll use the same method as option number 1. Take T as identity transformation. So the minimal polynomial of T will be equal to the minimal polynomial of the identity transformation, and the minimal polynomial of the identity transformation is, so we have the minimal polynomial of T is x minus 1 to the power n. So for the identity transformation, it cannot happen that the minimal polynomial of T will be x minus 1 to the power n minus 1. That cannot happen for the identity transformation, and identity transformation satisfies the condition that 1 is the only eigenvalue. So it is not true for the identity transformation. The option 2 does not hold. Now we'll check the option 3 and 4. So the property given here is 1 is the only eigenvalue of T. So the minimal polynomial of T will be of the form x minus 1 to the power k, where k is a natural number between 1 to n. That means the characteristic polynomial of T will be x minus 1 to the power n, because the roots of characteristic polynomials has to be the roots of minimal polynomial, and characteristic polynomial does not contain any other root than the minimal polynomial. The characteristic polynomial should be of degree n. We have x minus 1 to the power n is 0. This is our characteristic function. And from Cayley-Hamilton theorem, we can say that T minus the identity transformation to the power n is 0 from Cayley-Hamilton theorem. So for every linear transformation satisfying the condition, we have T minus identity transformation to the power n is 0. So option 3 will be a correct option. Now for option 4, it can be easily checked from option 3. We have that any linear transformation satisfying this property has a characteristic equation of this form. So if we multiply T minus identity on both sides, we'll have T minus 1 to the power n plus 1 is 0. So for any transformation satisfying the given property will always satisfy the option 4. So this will also be the answer. So the answer for this question is 3 and 4.